Hello! In this video I will be talking about free open source modular synthesizer VCV Rack. We will look at some modules and we will build a synth patch. In order to do that, we need a computer and a VCV Rack, which is free, and you can download it from the VCV Rack website. You also will need a controller, and you can use your computer keyboard as a controller or any other device. This is what you see when you open VCV Rack. It is a demo patch, and since I want to start from scratch, I will delete these modules. To delete a module, you first click on it and then press the delete button. You can add a new module by right-clicking on an empty space on the rack or by pressing enter. Let's look over some modules in the VCV library that we will use today. We have oscillators. VCO is a voltage-controlled oscillator that generates raw tones at a particular frequency, controlled by a voltage signal. We also have a VCF, a voltage-controlled filter. It removes a range of frequencies from an audio signal, with its cutoff frequency controlled by an external voltage. We have VCA, a voltage-controlled amplifier that allows the level of an audio or CV signal to be controlled by another CV signal. Also, here is ADSR. ADSR generates an envelope with attack, decay, sustain, and release. It's used to make the sounds more like acoustic instruments, which all have ADSR and not just on and off. We also have a mixer, a scope, and a sequencer. The MIDI CV module generates MIDI notes when keys are pressed, while the rack window is focused. And the audio module merges the virtual rack world with the physical hardware world. Let's start by adding an audio module and an oscillator. And here is something important. We need to select an audio device on our audio module. I am using screen record with audio as my output. It is what I use to record VCV sounds while recording my laptop screen. But you can use your laptop's built output or whatever interface you are using. If you don't choose an audio device, we won't hear any sound because VCV Rack won't know where to send the audio. Now we need to connect those, and let's talk how modules interact with each other. In Rack, input and output values carried by patch cables are in voltage units. Voltage is the difference in electric potential between 2 points. Modules can output several types of voltage signals. For example, pitch CV controls frequency, and VCV modules use the 1 volt per octave standard for CV control of frequency information. When you increase voltage for 1 volt, it will double the frequency, which means it transposes the pitch an octave higher. Trigger produces 10 volt with a duration of 1 millisecond, so you can think of it as of a short spark that triggers processes. And gate produces 10 volt when active. When gate is open, it will produce 10 volt until we close it. Let's connect our oscillator's sine wave output to the audio module. And here is our sound. On the oscillator, we can alter the frequency by dragging the knob up or down. And here is a little trick. Hold Ctrl or Command key on Mac while dragging to fine-tune. You also can right-click knobs to edit or double-click to initialize. It would be nice to have another form of control rather than connecting or disconnecting a cable every time when I want to start or stop the sound. And it is what we have our controller for. To control the sound with my keyboard, I need 3 new modules. First one is MIDI CV module. This is a module that generates MIDI notes. Another module that I need to add, it is VCA module. And VCA allows us to control the level of an audio signal or CV signal by another CV signal. And the last one, I want to add an envelope generator, ADSR. On the MIDI CV module, we need to select our controller, and I'm choosing computer keyboard, and you can select whatever controller you use. Then for my MIDI keyboard, I select QWERTY keyboard. That's what I will be using. Now we need to connect gate of the MIDI-CV model to the gate of the ADSR model. And as we remember, gate produces 10 volts when active. When gate is open, it will produce 10 volts until we close it. So when we press a key on our controller, it will constantly produce 10 volts. I connect volt per active output of the MIDI-CV with the input on our oscillator. I also connect the output of the ADSR to the VCA model, and it allows us to control the level of our audio signal by the ADSR model. I connect the wave output of the oscillator to the VCA's input, and the output of the VCA to the audio model. Let's see if it's working. I will press keys on my keyboard now, and we should hear a sound. At this point, I want to add a sequencer. Sequencer is a model that sends signals automatically in an organized way. I select sequencer 3. It will send out gate signals. For our sequencer, I want to set up another oscillator similarly as we have done before, and I will refer to it as oscillator 2. So I'm adding another VCO model and another VCA and an ADSR model. I'm placing all these models underneath the existing ones. Now patching. I connect the output of the ADSR to the VCA model. And I also connect the wave output of the oscillator 2 to the VCA's input. I connect the gate of our sequencer to the gate of the ADSR. I also connect the output of the VCA to the audio model channel 2. Now we have the audio signal triggered by our keyboard in channel 1 and the audio signal triggered by sequencer in our channel 2. Let's look at our sequencer model. The Run button will start the sequence. You can program the sequence by clicking on the green buttons at the bottom of our sequencer. The clock knob will adjust the tempo of the sequence. Here also I can do right-click knob to edit, or I can do double-click on the knob to initialize it. One of the last things I want to show to you today is how to add a filter. In our models, I'm selecting the VCF model, a voltage-controlled filter. It removes a range of frequencies from an audio signal with its cutoff frequency controlled by an external voltage. I will add a low-pass filter with a sawtooth wave on our oscillator 1 and have the cutoff frequency change with the sequencer. Now I connect the drive input of the VCF to the gate output of the sequencer, and the input of the VCF to the output of the VCA of our first oscillator. Since we are using a filter, I will disconnect the output that used to go from VCA to the audio model, and I will connect the output from the VCF to the audio model. At this stage, I want to add a mixer model. Now the sound produced by our oscillators will first go to a mixer. Oscillator 1 will go to channel 1 and oscillator 2 to channel 2, and mixer will send out a mixed signal. Let's test if it's working. Let me adjust the parameters related to the first oscillator so that we can tell the difference from the second oscillator. I change the sound wave to a sawtooth wave, and I adjust the frequency, and I also adjust the filter parameter. Additionally, I add a longer attack and a longer release. And hear how it sounds. I turn down channel 2 on our mixer so that we don't hear the sound coming from oscillator 2. And let's listen how it sounds when our filter is controlled by a sequencer. Let's listen to the sound produced by oscillator 2, and I'm raising the level in the mixer. I will press a key on my keyboard so that we hear two sounds together. The last thing I want to add today is the record model, so that we can record our results. I'm selecting the record model, and I will connect outputs 1 and 2 of the audio model to the record model. I will start the sequencer now, and to record it, you just press this large button on the record model.